Thoughtful, modern generative AI is exceptional at creating things that look plausible, but plausibility is not the same as causal fidelity. An algorithm can render a perfectly crisp shadow, even if that shadow moves in complete defiance of the actual light source. Take this viral image. It appears to show Elon Musk holding an unreleased yellow Tesla phone on a factory floor. To a human scrolling a feed, it looks real. Traditional deepfake detectors look for isolated pixel errors or blending artifacts. As generation models improve, those superficial errors disappear. The pixel checkers fail here because they do not understand the physics of the scene. To authenticate a digital asset today, we have to stop looking at pixels and start measuring reality. This requires a transition to the Cesare Protocol, specifically the ITA VQ version 2.1 framework. This diagram outlines a deterministic multimodal reasoning engine. It relies on a polydactic hypergraph feeding into a meta-analytic controller. Standard AI only guesses what looks right. ITA VQ calculates what is physically, geometrically, and historically possible, returning a precise metric known as the Veracity quotient, or VQ. To understand how this engine works, we first look at how traditional fact-checking models fail. They rely on dyadic graphs, connecting one piece of data to exactly one other piece. When you try to verify millions of intersecting pixels and semantic claims, mapping every point-to-point relationship creates an exponential math problem. The computation bottleneck makes real-time verification impossible. That dyadic approach also fragments the truth. If we try to verify the phone, the person, and the factory lighting as isolated pairs, the system misses the holistic contradictions in the image. The architectural solution is to use polyadic hypergraphs. A hyperedge encapsulates multiple interdependent nodes into a single unit, creating a complete visual ensemble. Grouping these dependencies reduces the computational complexity to a linear scale. The system can process the entire scene at once. Applied to our case study, a hyperedge binds the geometry of Elon's face, the product history of the phone, and the specific behavior of the factory lighting into one verifiable unit. If a single physical or semantic law within that ensemble is broken, the entire hyperedge is immediately invalidated. Truth cannot be isolated into disconnected pairs. It exists in multidimensional, unbreakable ensembles. This brings us to the core of the version 2.1 architecture, a strict 9-pillar foundation. We start with the legacy core, specifically Pillar 6 for visual integrity and Pillar 2 for anchor physics and lighting. When the system runs the factory image through these pillars, it flags an immediate contradiction. The reflections on the yellow phone casings do not align mathematically with the overhead light sources in the scene. Visual physics alone is insufficient. The system requires semantic verification, governed by Pillar 4, historical integrity. Pillar 4 checks the assertion against the chronological record. There is no historical data or supply chain record of a yellow Tesla phone entering mass production. For multimodal assets, Pillar 5 tests Audible Integrity, mapping spectral manifolds to detect artificial voice cloning or spliced frequencies. Returning to our image, Pillar 4 confirms its exact historical deviation. The background is plagiarized directly from documented photographs of a lava plant in India. Furthermore, cross-referencing authentic biological data highlights severe anatomical and morphological deviations in the generated face from the factory image. By binding rigid physical laws with strict historical records, a single generative model cannot fake the physics and the history simultaneously. Here, we see how the 9 pillars operate within the system execution pipeline, tracking data from the textual truth logic channel into the deterministic verification harness. This initiates Tier 1, the vibe check. The system runs a rapid baseline anomaly detection across all modalities. The data then enters Tier 2, handled by the self-correcting delta transformer. This transformer mathematically isolates the high-entropy deceptive hyperedges we found, like the false lighting and the plagiarized background, and annihilates them from the valid dataset. What remains moves to Tier 3, the predictive action orchestrator. The orchestrator acts as a neurosymbolic physics engine. It runs Monte Carlo tree search simulations to test the causal logic of the scene. It actively queries the data, running simulations to see if the captured light transport obeys the inverse square law. This three-tier loop converts static deepfake detection into an active, continuous simulation of physical reality. Relying solely on a 9-pillar loop leaves a critical vulnerability. A bad actor can use an authentic image with perfect technical metadata and flawless lighting to frame a manipulative omission in a text prompt. To solve this, the protocol integrates a parallel oracle module. The oracle is a continuous learning neuromorphic layer. It operates strictly outside the 9 columns to protect the epistemological rigor of the physical tests. The oracle's core query evaluates context. It asks, does this complete narrative make holistic, human sense within the current global landscape? Based on this assessment, the oracle assigns a final positive or negative modifier to the base veracity quotient. Flawless mathematical logic is required to prove an image is real. Understanding human context is required to prove a story is true. The final mathematical synthesis of the protocol combines these two distinct forms of reasoning. Running the yellow Tesla phone image through this pipeline generates a definitive ITA VQ audit report, resulting in a VQ score of 0.05 out of 1.0. Because of the collapsed hyperedges in physics and history, the system triggers an extreme fraud hallucination classification. Compare that to an authentic, verified product, like the Tesla bot. An actual photograph maintains cohesive lighting, accurate geometry, and historical alignment. Finally, this schematic details the meta-analytic controller, illustrating the closed-loop nature of the architecture. The Veracity Quotient data stream feeds directly upward from the hypergraph, providing continuous feedback to dynamically optimize the harness parameters. The Cesare Protocol serves a singular overarching purpose. It acts as the immune system for reality. ITA-ZQ restores trust by anchoring artificial intelligence not to probabilistic text generation, but to the verifiable, unyielding laws of nature. The final mathematical synthesis of the protocol combines these two distinct forms of reasoning. Running the yellow Tesla phone image through this pipeline generates a definitive ITA VQ audit report, resulting in a VQ score of 0.05 out of 1.0. Because of the collapsed hyperedges in physics and history, the system triggers an extreme fraud hallucination classification. Compare that to the forensic baseline of an authentic, verified product, like the Tesla bot. An actual photograph maintains cohesive lighting, accurate geometry, and exact historical alignment. Finally, this schematic details the meta-analytical controller, illustrating the closed-loop nature of the architecture. The Veracity Quotient data stream feeds directly upward from the hypergraph, providing continuous feedback to dynamically optimize the harness parameters. Ultimately, the Cesare Protocol serves a singular, overarching purpose. It acts as the digital immune system for our shared reality. ITA-VQ restores trust by anchoring artificial intelligence not to probabilistic text generation, but to the verifiable, unyielding laws of nature.